All right, this is a great question. We're looking for solubility, but in this question we have a common ion. It's a little bit hidden in that we're given pH, but pH is essentially that ratio of H3O plus to OH minus, and if it's above 7, then we have more OH minus than we have H3O plus, and OH minus is a common ion to CrOH3. Chromium hydroxide. So we first have to figure out what is the concentration of this common ion, knowing the pH, and then we can solve for our solubility with the common ion in it. And again, we're given KSP, which is very small. So we can use that X as small approximation. Okay, so first thing we need to do is figure out what is the OH minus concentration. So what I would do is solve for POH, which is 14 minus pH. So 14 minus 11.10 equals 2.90. And then from that, we can solve for OH minus concentration by doing 10 to the negative POH. So 10 to the negative 2.9 equals, plug that in. Don't forget the negative. 1.259 times 10 to the minus third. So pretty good concentration. That's pretty high pH. So now we have this common ion. So we can write out CrOH3 is going into solution with Cr plus 3 plus 3 OH minuses. So don't forget about that 3 in front, which will also show up in our equilibrium expression. So we got 0 of this, but we have 1.259 times 10 to the minus third of this. So we're gonna plus 3s, don't forget that. Although it does get subtracted out in this. So our KSP is equal to OH minus and then cubed. Don't forget that 3 there. Now we know KSP is 6.70 times 10 to the minus 31. We have an S. And then here we have 1.259 times 10 to the minus 3 plus 3s cubed. Now X is small, eliminates this, which actually simplifies our math a little bit. So we're going to take that 1.259 EE negative 3 and raise it to the third power, which is equal to S times 1.996 times 10 to the minus 9th. So I'm going to divide that out from the KSP. So 6.70 E minus 31 divided by 1.996 EE minus 9 equals S. So S equals 3.36 times 10 to the minus 22. So I keep extra significant digits as I'm working through, and then I go down to the 3 when I am finished. So 3.36 times 10 to the minus 22nd. So very insoluble still, especially with that common ion. So we're in a pH. If we had a low pH, we would actually help the concentration because we would react some of that OH minus with the H3O plus in the acid. So this is a good example of Le Chatelier's principle. We did not solve for the molar solubility in just water, but that would actually be higher than with a pH of 11.1. So great common ion example. We still solve it the same way. We just now have that common ion, which actually simplifies our math a little bit with the X is small approximation.